So section 3.6 is dealing with inequalities on graphs, and everything you need to know really is in these 2 bullet points at the bottom of page 51, but this is the sort of thing which is difficult to turn into a sentence, and the algebraic notation sometimes makes things look a bit complicated. So let's just think about this on a set of graphs. Here is a function. It doesn't matter what shape it is. It doesn't even have to be an equation that we could describe. You know, it's just any old function. Here's f of x, and here's another function which looks suspiciously like a quadratic, but there we go. If I want to know when is g of x less than f of x, well, you can perhaps see that that is going to be this bit here. The curve for g of x is underneath the f of x curve in this bit here. So if I take that x value there and that x value there, between those 2 x values, g of x is less than f of x. If I wanted f of x to be less than g of x, well, here the f of x curve is below the g of x curve, and here the f of x curve is below the g of x curve. So there are 2 parts, this one here and this one here. Oh, sorry, this one here going off to infinity, and this one here going off to infinity as well. There's no sort of, these aren't really double-headed arrows, are there? It's this bit here and this bit here. So there's 2 parts of the number line. I need to represent that with 2 inequalities. Now, if you read the black bullet points on the bottom of page 51, the bold bullet points, I mean, that makes sense. What they say there is exactly what we said here, but it's perhaps a little bit easier to see it from a diagram and imagine it from a diagram. So that's all there is to add there, really. Be careful with strict inequalities and not strict inequalities. Draw a diagram, do a quick sketch of the graphs. That is going to help you an awful lot. And that's an advice I know that you get in stats and in mechanics and in pure maths and a lot of the time. And the reason it's sort of cliched advice for maths is because it's good advice, right? If you draw a diagram, it is always, well, not always, but a lot of the time, a diagram will help you picture what's going on. If you can picture what's going on, you're less likely to make a mistake. So draw a diagram, look for where one curve is below the other. And of course, if we're looking for where one curve is below the other, the crossing points are important, right? So if I can find the x-coordinate here and the x-coordinate here, that will solve my question for me. And we know from earlier on in the chapter that where the 2 graphs cross, take the equations and solve them simultaneously. So that's now a fact that we're kind of taking as read, that if we want to know where 2 graphs cross, we have the method. It doesn't necessarily mean it's easy to do, but we know what the method is. It's take the equations and solve them simultaneously. Don't get bogged down in the algebra too much, we hope. And then once we've got the solutions to the simultaneous equations, we take the x values, and that will tell us the numbers that we need for our inequality solutions. So, in summary, draw a sketch and use techniques that you are already familiar with. That's the end of section 3.6.